How's it going, guys? Welcome to another video on matrices. Today we're going to have a look at chapter 8.5. So this is on multiplicative inverses and solving for matrix equations. So chapter 8.5. So just remember, we've had a look at the situation where we can't divide matrices by other matrices. So in this chapter, it's going to look at ways to get around that fact that we can't divide matrices by other matrices. So just a bit of arithmetic. So recall that any number multiplied by its reciprocal or its multiplicative inverse results in 1. So for example, if we have the number 8 and we multiply it by its reciprocal, which is 1 over 8, 1 times 1/8 is going to be 1. So that's what we're talking about when we talk about multiplicative inverse, or the reciprocal. So that's with just ordinary numbers, but we're going to do the same similar thing with matrices. So we've got the situation, we've got this matrix, we'll call this A, and we don't know what this one is, so we'll call it B. So we're multiplying matrix A by matrix B. So matrix A is 2, 3, 3, 5, matrix B, 5 minus 3 minus 3, 2. So we can do that just by hand, and it'd be a good opportunity for you to pause the video now and have a go at multiplying these two matrices out. So just by hand, using our train method, so you can draw your trains in like this. So here's our engine and our carriage. Alright, where does the train go? All the way down here. Ends up stopping at this stop here. Okay, and so we start off with 3 times minus 3. And 2 times 5. Okay, so fill out the rest of those spots in there. So pause the video and have a go. Alright, once you've filled out those, we'll work out, so you should get this, so 2 times 5 plus 3 times minus 3. If you work that out, you should get a 1. In the next position, 2 times minus 3 is negative 6 plus positive 6, we should get 0. Down here, 3 times 5 is 15 plus 5 times minus 3, we'll get another 0. And then over here is a similar case, we'll get 1. So you should notice we've got a special matrix here. So we've got 1, 0, 0, 1. So recall that that is actually our identity matrix. Alright, we've got 1s along the diagonal and 0s everywhere else. So again, notice that the answer is the actual identity matrix. So that's an important point there. It means that the one matrix is the multiplicative inverse of the other. So because we multiplied one matrix, A, by matrix B, resulting in the identity matrix, it means that one matrix, either A or B, is the multiplicative inverse of the other. And this is a summary here. So if A, matrix A, times another matrix, usually denoted like this, so A to the negative 1, is equal to the identity, or the other way around. So the inverse times the original matrix equals the identity. Then we can say this matrix A to the minus 1 is the multiplicative inverse of A. So in our example, we had A times B, and we resulted in the identity. So we can say that B is the multiplicative inverse of A. And what we should write instead of B is B should actually equal a to the minus 1, or the inverse of a. So that's what we're looking at. So that's the official definition, so it'd be good to copy that down. The next question you're probably asking is, how do we find the multiplicative inverse? And it's actually not quite, there's a few steps involved. First thing we haven't looked at is what's called the determinant. And we need the determinant to work out our multiplicative inverse. And it's a good thing, or a good idea, to break the steps down into smaller parts. So if I have matrix A, and I've got elements in the matrix A, B, C, and D. To work out what my determinant is, this is how I write determinant. So instead of having to write it out all the time, it's just det. Det of A means the determinant of A is equal to the element A times the element D. It's a D. And we're taking away element C times element B. So it's AD minus BC. And we work out that. So for our example before, we had the original matrix 2, 3, 3, and 5. So let's work out what that determinant was. So it's 2 times 5 and 3 times 3. And what do we get? Well, that's 10, take 9, so we actually get 1 for our determinant. The next step, I'll just write that out again. So we've got a determinant of A equals 1. Our next step is to use the formula to find our inverse. And this is what it looks like. Now I could put that determinant as, I could write this part as 1 over AD minus BC, but I think it's better if you break it down into smaller parts. So work out what your determinant is first and use that into this formula here. It doesn't matter if you want to just do it all as one big thing, that's fine. That's up to you, what you want to do. So 1 over the determinant times by our original matrix A, except we've swapped A and D. So the position of A and D have swapped, and negative B and C. So B and C stay where they are, it's just that they become negative. So we've swapped those two, and these become negative. So our matrix that we had before, our determinant was 1. Our position of A was 2, or element A was 2, so that now comes down here. Element D was 5, so that now comes up here. Element B was a 3, so that now becomes minus 3. And element C was a 3 as well, so that becomes minus 3 there. Usually you'll have a different number for the determinant. In this case it makes it quite simple because it's 1 divided by 1 times everything in there. If it was a 2, so just for instance sake, let's say it was a 2, then we'd go 5 times a half minus 3 times a half, etc. But we don't need to do that because it's just a 1. So our inverse matrix is 5 minus 3, minus 3, and 2. So if we go back to our second slide, which was this part here, that's the matrix we had for B, 5, minus 3, minus 3, and 2, resulting in the identity. So that's how they got that matrix there at B. So we started with A, we found the determinant, worked out what the multiplicative inverse is, and that's what we have for our other matrix. So a couple of steps there. This is probably the most confusing part, so don't get those swapped around. So they just become negative and we just swap A and D. It will take some practice to work out all this, but that is what you want to have written down as finding the determinant and the multiplicative inverse. Now, another thing to note is because when we're finding the inverse, we have to divide by the determinant. What happens when we divide, or what happens if we work out that the determinant is 0? So let's say we had another matrix A, completely different to what we had before, but we work out that the determinant is 0. Well, the problem is 1 divided by 0 doesn't exist. So it means that there's no multiplicative inverse. It also, we can denote it as what's called singular, meaning it doesn't have an inverse, it doesn't have, well, the determinant 0. So that's all that's meaning. So if you see singular and regular matrices, it just means that we've got a determinant of 0 and we don't have an inverse matrix for that one. When we find our inverse, so let's say we've got the equation AX equals B and we want to solve for X. And we've got matrix A that might be 1, 3, 4, and 8. Not sure what it is. And we're multiplying it by X, generally the matrix XY, and that equals B, which might be 1 and 2. So we want to solve this equation, and we work out what the inverse of A was. So what we need to do is when we find the inverse of A, we need to multiply it next to the position of A. So for this case, we would have to multiply it on the left. So we'd say the inverse of A times A, and the inverse of A times A gives us the identity, or 1. Basically means we're multiplying by 1 now. So when we do that, we need to do the same thing in the same position on the right hand side, because what we do to one side we've got to do to the other. Multiply it on the left, we've got to multiply it on the left. Basically they cancel out and become the identity. Alright, it's just like multiplying by 1, doesn't do much. Okay, so we can say our identity times x, or it's just x, is equal to our inverse times the matrix B. And we do that because we started with A on the left. So if you have to multiply on the left, if A is on the left, you multiply on the left, you do the same on the right hand side. The other situation is if we had x times A equals B, then we'd have to have the situation x times A inverse. So we're multiplying by the inverse on the right. which means on the right hand side we do the same thing. Alright, so what you do on one side you've got to do to the other. Okay, again they cancel out, we get x equals b times a to the minus 1. So in summary, we can say if ax equals b, then x equals a inverse times b. Okay, again, a was on the left, so we multiply it on the left. If xa equals b, then x equals b times a inverse. So it's the other way around. Okay, so two situations. If it's on the left, do the same thing on the left. If it's on the right, do the same thing on the right. That's pretty much all you need to remember. So I'm going to leave the video here. I'm going to do another video on a couple more examples. So stay tuned for the next video. Thanks.